is it possible to do a transformation and some of the one or more of the points don't move? They stay exactly where they are. Is that possible? Have we seen that? Yes, we have. Okay. And that's what I'm going to start referring to as invariant points. All right. Invariant points. It is a points that do not move or change, points that do not move after a transformation. So don't call them points that don't move anymore. Call them invariant points. I'm not asking you to graph this. Please don't. All right. I just have it up here, though. Here's what I want to know first. I'm going to say point B. Point B is going to be invariant after I do something to it. What's that something? So give me a transformation we've discussed and get specific where point B would end up right where it is at 0, -3. All right. That's what I want right now. Do this. And it won't move. Okay, do this and it will not move. All right. Here we go. 19. Any suggestions? Reflection over the y-axis would make it invariant. Yep. And since this is an honors level class, I'm going to go for one more. And please don't tell me translation is 0, 0. All right. Don't tell me rotate around point B. All right, those are always going to be ones that we could use. Give me something else. There's something else. You got something, Sarah? What type of line is y equals any number? Horizontal. So if I go reflect through this horizontal line, y equals -3, that's not going to go anywhere. Yep, good. Point B is not going to go anywhere. All right, let's move to point D now. Give me something where point D won't move. All right, we'll stay exactly where it is for point D. 4, give me something. All right, good. X equals what type of line? Vertical line. So vertical line going through 3. That D is not going to go anywhere. It's on there. And I could also do no more translation to 0, 0 or rotate around point D, but 6. Reflection through the x-axis. So everyone all right with this new term, invariant? Doesn't move. Stays right where it is. Doesn't move. Questions? Okay, good. Got through that. Now let's talk about dilations. Because I think there's a huge misconception that I have to change in your mind today. Okay, we're going to dilate by 2. Bigger or smaller, triangle ABC? Absolutely bigger. That's what you guys know, but why does it get bigger? That's what I got to drive home today is why does it get bigger? Because take a look. Yeah, the triangle's going to get bigger, but hey, take a look. Is point A going to get physically bigger? Probably not. So why does this triangle get bigger? Here's why. Everyone agree. A has some distance away from the origin. B has some distance away from the origin, and so does C. Everyone agrees. All right, here's what you're going to do with the dilation of 2. You're going to double that distance now. So how far away is C from the origin? 4 units. Guess how far it's going to be now? 8 units. That's why the triangle is going to get bigger. Because all these points, A, B, and C, are going to double its distance away from the origin. So how do you find the actual coordinates? I think I went over this quickly for one of the homework problems. You're going to take each coordinate, x and y, and you're going to multiply it by the scale factor. All right? So you multiply x and y by the scale factor. So here we go. Number 9, A prime. B prime, C prime. Watch how all the points now get further away from 0, 0. That's why the triangle gets bigger. One half. What's going to happen to the triangle? Why is it going to get smaller? Because now A, B, and C are going to move closer to the origin. All right, they're going to move closer. And make sure you know we're doing it on triangle ABC, not the previous one, triangle ABC. So here we go, A double prime, B double prime, C double prime. Who's got those coordinates? Number 13 got those coordinates here, A double prime. Yep, B double prime. And C double prime. Okay. Watch the triangle get smaller now because all the points are coming closer. Okay. Do we understand? Now we see if the scale factor is bigger than 1, points are going to get further away. And then once the scale factor is between 0 and 1, they're going to get closer to whatever point we are dilating around. Is it always going to be the origin? No. We are not always going to dilate around the origin. And we are also not just going to dilate triangles. Here's an example where we're going to dilate a line. But I don't know, anybody thinking to themselves right now, how does a line get bigger? That doesn't happen. Okay. Well, lines go on forever. All right. So I can't really make it any longer, right? So how am I going to dilate a line? Well, a line's made up of what? Infinitely many points. So those points can either get further away or closer to a certain point. So take a look. Before I talk about the line, we're going to dilate it by 1/3 around 4,2. No more origin, 4,2. So based on what we just did last problem, and don't yell it out, I'm going to call on somebody. Are all these points on the line going to get closer or further away from 4,2 based on the scale factor? Further away or closer to 4,2? 5, further away or closer to 4,2? All right, just totally my mojo. 6, closer or further away? Closer, because it's between 0 and 1. All right, so all points are going to get closer to 4,2. All right, so try to envision that now before we graph it. Is all points on 3x plus 4y equal 20 are going to move closer to 4,2. All right, let's graph this sucker so I can see what I'm dealing with. Yikes, I can't do much with that. Can somebody help me get it into y equals form? 14, what's my first step getting to y equals form? Okay. So we end up with 4y equals negative 3x plus 20. My next step, getting that into y equals form. Here we go, 23. Do we have one?
Yeah. Divide everything by 4.
Okay. So here's what I need you to graph. Y equals negative 3/4 x plus 5. Where's the first point you can graph? What's your y-intercept? Okay, everyone go ahead, graph 5 on the y-axis. And I'm going to need a couple more points here. How do I find more points? What's my slope? Negative 3/4. So tell me directions I could go here. Down 1, 2, 3. Right 1, 2, 3, 4. Or I could go up 1, 2, 3 to the left. 1, 2, 3, 4. Grab the straight edge. graphing that line. All right. We just discussed all these points are going to get further or closer away to 4-2? Closer. Why don't we find out where 4-2 is? Go ahead, find out where 4-2 is. You just leave it there, okay? Thank you. Where's 4-2 located? All right, let's discuss here now. Here you go. This point here, it's going to get closer to 4-2, right? So where's it going to end up? Somewhere on the line. Take this point. It's going to get closer to 4-2, but still end up where? On the line. Every point you test will get closer to 4-2, but it's going to end up where? On the line. So what can you tell me about my new line that we're calling P? Line P. Am I going to graph a new line here? No. What's it going to be? Same one I started with. 3x plus 4y equals 20. So if your center of dilation is on the line, it's going to stay the same line. Okay? Now, if it's off the line, different story. We'll have to talk about that. All right? But if your center of dilation is somewhere on the line, you're dilating, it's going to stay the same line. Does that make sense? How all points are going to get closer, but they're going to remain on the line. Okay there? Is this? No, not yet. We're not ready yet. All right. Kind of like yesterday. Remember you proved the triangles were congruent. All right, well, what happened here? ABC to A prime, B prime, C prime. Well, I'm not ready to prove them similar yet. I'm asking, part A says, describe to me what happened. What did we do here? Okay, we enlarged it. So what transformation is that? Okay, so a dilation, right? But as you guys learned from yesterday, the one word won't cut it. A dilation with scale factor. Got to tell me what we're dilating by. I'll let you guys figure that out on your own. What's your scale factor here? In the correct order, because you are enlarging it. Scale factor. 9 scale factor. What is it? 2.5. If you left it 5 over 2, 15 over 6, that's fine too. Okay. What? What do you mean the 2 points? Yeah, that's fine. All right, why are they similar? Why are they similar? They changed the distance, right? So I can't write the rigid motions or anything, but they do preserve what? Angle measure, right? So dilations, I'm not saying the rigid motions, that's for sure. Dilations preserve angle measure. Thus, triangle ABC. Be careful, be careful. Make sure you write the tilde. Similar to triangle A prime, B prime, C prime. The next one you're going to do in your group. I really don't want to say anything about this one because there's multiple ways of doing it, and I'm interested to see if the whole class does it the same way or it's a half and half split. We'll see. Okay, so discuss it in your group. See how you want to attack it. Okay, I need to know what you and your group decided to do. 9.
We dilated the points.
So you dilated the point first and then found the distance. Did anybody cut it in half, then find the distance? Did anybody? No, did anybody find the distance and cut it in half? Because that's the other way to do it. So either you dilate the points first, then use distance formula, or you use distance formula first and then cut it in half. Either way, what'd you get? What do we have for the final distance of A prime, B prime? What do we end up? Final distance here, 20? 20 in the house? 2.5. Anybody want to work through those at all? Okay, I'm going to let you go in your group one more time just to make sure you guys have the scale factor business down and you can do the actual dilations. So go right ahead. We're dilating around 0, 0, so you can multiply them. And then I'll ask a couple groups in a second what they ended up with. One at a time here. Let's start with number 17. P prime, Q prime, R prime of numbers, the first triangle. Got it? Q. Yep. Yep. Again, you can have the decimals if you want. That's fine. Leave them. And then R prime. Perfect. All right. Let's go to the next one there. Now we got a dilation of 3. Here we go. 7. Dilation of 3. Negative 21.6, yep. 324, yep. Okay, any issues so far, guys? Any issues? And one more before we go construction time. Here you go. One, go ahead. Yep, Q prime. R prime. Okay, nice job. Anything else, guys? All right, have your compass straight edge ready to go now. Oops. Just give me a second. I got something else I want to do with you before we leave. Okay. All right, take a look what I'm asking here. Let's see if we've learned anything from today. We're going to dilate by 1/2. What's that mean about A, R, and T? I don't want to hear the triangle get smaller anymore. We're all very clear in that. A, R, and T are getting closer to what point? O, by 1/2 the distance. Let me say that again. By 1/2 the distance. This is not a new construction I'm going to show you. Everybody connect R to O right now. Connect R to O. Connect R to O. How can I find half, the middle, where I could put R prime? I'm going to do the perpendicular bisector, yes. Something we've used multiple times this year. Open it up more than halfway. Make a good size arc. Keep your compass open the same. Go to the other end point of the segment. Now I will lend you a little piece of advice here. So you don't have all these lines flying around. Do not line up your straight edge and draw the line through. I don't need that line. Here's what I need. I need you to line it up. Take a look. Line it up. There's no need for this full line to go there. What am I concerned with? Where it hits RO. And I'm just going to make a little mark, and there it is. Halfway close. I close the distance by half. R prime. Okay? So let's do that for T to O and A to O. Let's close the distance by 1/2. And then hopefully our result is a smaller triangle that's closer to O. And then I got a bonus question for you. Okay, we look all right. All points getting closer. And then I'm going to leave you guys today with this question. Here we go. Because question number 10 is for the assignment, which I'm going to check on Monday. All right, I'm still going to check the dilation homework. It'll just be on Monday. Here's my question for you guys. Same diagram, same center O, but now I'm going to change that 1/2 to a 2. What's your move now? Because I don't need a perpendicular bisector anymore. Now I'm getting further away by twice the distance. What's your move now? Because I don't think a perpendicular bisector is going to help me. Evan, what's your move? Okay, so I would find the distance from R to O. This way? But I didn't change the distance though, right? Everyone agree if I do it that way, I didn't change the distance. And plus, remember, when you do a dilation, does it reflect through the point? No, right? It gets further away in the same direction. So really what I need to do is do what over here? Extend that over here and now put compass point on R and do my arc over here. And now that's where R prime would be. Okay? All good there? And would I get crazy and do a 3, a 4, a 1/4? Probably not. It'd probably just stick with the scale factor of 2 1/2. Okay? Questions? All right. Get after it tomorrow. Get work done. I'll probably have like 5-10 minutes on Monday if you want to answer any questions, and then we start the circle unit.